We are pleased that you are devoting time to learn about our new product, SurveyIR. We will start with an introduction to FTIR Microspectroscopy and the SurveyIR product. Then we will discuss several examples from two microanalysis application areas: micro defect or contaminant analysis and criminal forensics. We'll then follow up with some conclusions. Let's get started. Infrared microscopy. What can it tell me? We will start with a brief introduction of infrared spectroscopy. Infrared spectroscopy is concerned with the interaction of infrared electromagnetic radiation with molecules. When the frequency of infrared radiation matches the frequency of a fundamental mode of vibration in a molecule, the infrared light is absorbed and the molecule vibrates with increased amplitude, leading to the observation of absorption bands. The infrared absorption spectrum of water is shown at the upper right-hand side of this slide. The water absorption spectrum exhibits two prominent features, one at approximately 3,400 reciprocal centimeters and the other around 1640 reciprocal centimeters, corresponding to oxygen, hydrogen, stretching, and bending, respectively. The infrared spectrum of a material is very specific and represents a fingerprint of the molecule. Unknown samples can be identified by searching against libraries of spectra of known materials. Infrared microspectroscopy extends FTIR spectroscopy into the microdomain. With conventional infrared spectroscopy, we measure mass on the scale of milligrams and length on the scale of millimeters. Infrared spectroscopy is a bulk method. By coupling beam condensing optics and sample isolation optics, we can extend spectroscopy into the microdomain, where mass is measured in picograms and length is measured in micrometers. Infrared microspectroscopy is a micro method. Infrared microscopy. When is it used? When is it useful? With microspectroscopy, we have a very powerful system in that we can isolate areas of samples that we observe microscopically and target areas for infrared analysis. The image shown on the right-hand side of this slide pictorially represents this process. A sample with 3 different regions is observed. These regions, their contrast observed microscopically, can be targeted and infrared spectra recorded. The infrared spectra represent the chemical contrast of these regions. The applications of infrared microspectroscopy are very broad and diverse. An important application is the analysis of product microdefects in manufacturing, quality control, or originating from customer complaints. Defect or contaminant analysis is applicable to a very broad range of industries and consumer products. Infrared microspectroscopy can also be applied in authenticity or conservation analyses. Product or raw material verification is a similar application to authenticity determinations. Other important applications of infrared microspectroscopy include criminal forensics or identifying contaminants on electronics components. At this point, we would like to present the specifics of SurveyIR and how it's used in FTIR microspectroscopy applications. We believe that SurveyIR expands the application of infrared microspectroscopy into areas where microspectroscopy has not been used. Traditional FTIR microscopes are used in specialized labs due to the relatively high cost and user skill required to effectively use these systems. SurveyIR allows the identification of an unknown closer to the problem, even in portable applications. SurveyIR is affordable and easy to use and interfaces to virtually any FTIR spectrometer. SurveyIR will address new areas for infrared microspectroscopy, getting the solution closer to the problem, including into quality control laboratories, incoming materials labs, and closer to the process or factory floor due to the compactness of spectrometers and SurveyIR. SurveyIR can be transported to the field for use in out-of-lab analyses. SurveyIR is a routine instrument for routine microanalysis. The key product features of SurveyIR will now be discussed. SurveyIR is the only user-installed FTIR microspectroscopy accessory, is alignment-free, and can be set up in a couple of minutes or less. All power and data is interfaced to your computer over USB. No other external facilities are required. SurveyIR has a lot of flexibility and power in both microscopy and spectroscopy. There are 3 microscopy illumination modes: transmission, reflection, and oblique or dark field illumination. Oblique illumination will be discussed in some detail later. SurveyIR provides simultaneous visual and infrared signal observation. There is no switching between infrared and microscope operation. An integrated megapixel camera yields live images of the specimens and is used to capture digital images for later documentation. SurveyIR's large field of view allows ease in location of samples. Better than 3 micrometer optical resolution provides high image quality and clarity. Included eSpot software provides integrated control of SurveyIR, as well as capturing and saving images. Infrared spectroscopic measurements can be made in reflection, attenuated total reflection, or ATR, and transmission. A unique and very beneficial feature of SurveyIR is its view-through diamond attenuated total reflection capability. SurveyIR contains a variable remote image masks to isolate the sample area of interest. These masks are controlled automatically through the use of eSpot software. Another unique feature of SurveyIR is equal efficiency in reflection and transmission. With all other FTIR microscopes, reflection performance is 50% of transmission performance. SurveyIR provides outstanding features and performance and value. SurveyIR is available for virtually any FTIR spectrometer. Several examples are shown here, including an Agilent Technologies Carey Model 630, a Perkin-Elmer Spectrum 2, a Thermo Scientific Nicolay IS5, a Brooker Alpha, and Shimadzu IR Affinity. Many other brands and spectrometers can be addressed with SurveyIR. Please contact Czitek for compatibility with your model of FTIR spectrometer. We believe that SurveyIR is very easy to use, yet very powerful. Minimal setup is required. The system can be ready to measure samples within seconds. SurveyIR has a very simple, repeatable measurement procedure, ensuring that the focus of the infrared interrogation area is at the same spot as the visible observation area. There's no switching between infrared and visible objectives. SurveyIR has a large depth of field. even when the sample is not in focus, you are able to observe surface features and quickly bring the sample into focus. Lastly, SurveyIR has a large field of view. This allows the user to locate samples more easily and quickly. With SurveyIR, infrared microspectroscopy performance is not compromised either in microscopic image quality or infrared spectroscopy performance and flexibility. SurveyIR has unique features that are very beneficial to microspectroscopy users and application solutions. Oblique illumination is one such feature. As illustrated at left, oblique illumination entails the illumination of a specimen off-axis from the side and observing the scattered light coming from the specimen. With many specimens having surface irregularities or edges, the contrast and color definition is better with oblique illumination in comparison with other illumination methods. Another unique feature that is very beneficial is the view-through diamond attenuated total reflection, or ATR attachment. ATR is a contact technique. Samples are measured by bringing them in contact with a hard, chemically inert crystal, such as diamond. The SurveyIR Diamond ATR allows the observation of samples through the ATR element and visualization of contact, providing ease in use and confidence that the sample area of interest is analyzed. ATR measurements also minimize sample preparation. The image quality observed through the ATR is excellent, as shown in this image of sucrose crystals illuminated obliquely. eSpot video microscopy software is included with SurveyIR. eSpot allows control of SurveyIR's automated features, including the illumination controls, infrared measurement modes, masking apertures, and ATR forced readout. eSpot is also used to observe live video images recorded from the megapixel camera, to save images, analyze images, and document images. We will now present a few examples of the application of SurveyIR. First, we will discuss product defect analysis, as we mentioned previously. Product defect analysis is applicable to many different industries. Typically, a defect is not a problem unless it can be seen with the unaided human eye. The smallest size that an unaided human eye can observe is about 50 micrometers. Many humans cannot see sizes that small. Most visible defects are in the 100 to 200 micrometer range. This size is very well matched to SurveyIR's capabilities when interfaced to an FTIR spectrometer using an instrument-mounted DTGS detector. In the typical workflow, the defect spot is observed on a product in a production process. Samples are collected and submitted for analysis. The analyst determines whether the contamination is on the surface or below the surface of the product of interest. Both types of defects can be identified using SurveyIR, but the way they are approached is slightly different. With a surface-located spot, it is best to attempt the analysis with Diamond ATR, which is surface selective and minimize sample preparation, also providing an easier analysis. When the spectrum is recorded, typically the identification is made with the aid of spectral library searching, the automated searching of spectra of known materials. If the defect is subsurface, it is isolated and removed. The contaminant particle is placed on an infrared transmitting or reflecting substrate. Typically, the defect particle is rolled thin and measured by transmission using infrared transmitting windows or by double pass reflection off of low E glass. The unknown is identified as discussed previously. The first example presented relates to a customer complaint, contamination on the surface of a pharmaceutical tablet. An unmagnified image of the defect spot on the tablet is displayed at the upper left. On bottom left is a magnified image of the spot recorded through the diamond ATR using oblique illumination on SurveyIR. The infrared spectrum of the contaminant, shown in the upper right figure in blue, was identified as an ethylene-propylene copolymer. This material is typically used for gaskets in manufacturing processes. The infrared spectrum of the tablet, in red on bottom right, corresponds to hydroxypropyl methylcellulose, or HPMC. ATR spectroscopy is surface selective. The tablet coating is measured without interrogating the pharmaceutical active ingredient underneath. The penetration depth of diamond ATR used on SurveyIR is about 1 to 2 micrometers. This allows measurement of contaminants in situ without sample preparation. As discussed, embedded contaminants can also be identified by infrared microspectroscopy using SurveyIR. In this example, contaminant spots were present on an engineered plastic component, an automobile bumper part that was injection molded. Many such visible defects were noted on the parts in the factory. In the upper left, a magnified image of the contaminant in the plastic is observed. These contaminants were embedded and easily excised. The image of an excised contaminant, observed under oblique illumination, is displayed on the bottom left. The habit of the contaminant was that of an oily, granular material. The infrared spectrum of this defect, measured in transmission through a diamond window using a 160 micrometer aperture, is shown in the top right in purple. The major component of this contaminant was identified as silica gel. Silica gel is very common, and in this process silica gel was used as an anti-caking agent. It is believed that this anti-caking agent got into the process and contaminated the end product. The analysis of other product defects using SurveyIR will be discussed. SurveyIR provides high-quality microscopical performance in clarity with high image quality and confidence that microscopic observations are correlated with the chemical identification. In the next examples, the infrared analysis and identification of particulates in an injectable pharmaceutical will be discussed. In this case, particulates were observed in an injectable drug. They were filtered and measured directly on the filter using view-through diamond ATR. The next example is an analysis of contamination of a food or cosmetics additive where discolorization or staining was noted, and the contamination was analyzed directly using diamond ATR and oblique illumination. Suspended particles in an injectable pharmaceutical represented another customer complaint. At the upper left, we observe one of the particles on the surface of the filter used to isolate them. Again, this image was observed under oblique illumination through the diamond ATR element. The infrared spectrum of the contaminant is shown in red at the upper right and correlates very well to the spectrum of polytetrafluoroethylene, which is also known as Teflon, shown at bottom right. The SEPTA material in the injectable drug package was composed of Teflon, and it is believed that some of the SEPTA material contaminated the injectable pharmaceutical. Again, due to its surface selectivity, diamond ATR yielded the spectrum of the contaminant without observing the cellulose spectrum due to the filter, and also the contaminant was measured without further sample preparation after filtering. The next and last example for product defect analysis concerned a food and cosmetic additive, citric acid. Citric acid is a very common additive produced in large quantities. In this case, discolorization was observed in the powdered product. In the image at the upper left, this discolorization is observed in some of the crystals, again observed through the diamond ATR element using oblique illumination. An infrared spectrum of the contamination with citric acid present is shown at the top right. The contaminant was identified as hydraulic fluid, a corresponding reference spectrum shown in blue on bottom right. The source of the hydraulic fluid was a compromised seal in a pump used in the manufacturing process. In this particular example, there was a very large backlog of samples at the centralized R&D lab, and the user acquired the surveyor to perform this analysis directly on the manufacturing floor near the process. To conclude the discussion of product defect analysis using SurveyIR, the value proposition of SurveyIR in analyzing product contamination will be presented. SurveyIR makes FTIR microspectroscopy routine and allows companies to save costs and improve efficiency in defect analysis. Visible defects or contamination can cause financial losses in two ways. First, there is production downtime, and in many cases, the investment in FTIR microspectroscopy can be easily justified by reducing production downtime due to the poor quality. Another way that financial impact is realized is through customer or consumer complaints. A more rapid identification of the defect through infrared spectral analysis leads to faster resolution and a lower financial impact. One of the issues facing many producers is backlog in their centralized laboratory or in contract labs that are used for infrared microspectroscopy analyses. SurveyIR interfaces with low-cost FTIR spectrometers and provides a solution by allowing the microanalysis to be performed at the location of the problem. SurveyIR can upgrade your capabilities and get production back online rapidly. The application of SurveyIR in criminal forensics will now be discussed. FTIR microscopy is a well-known and accepted technique for forensic trace analysis. FTIR microscopy is commonly limited to larger labs and to skilled users due to the cost and complexity of traditional FTIR microscope systems. SurveyIR allows a quick analysis for virtually any sample type. SurveyIR brings FTIR microspectroscopy to smaller forensic labs with tighter budgets and out into the field to provide field-based microspectroscopy identifications. Typical forensic sample types include narcotic drug mixtures, paint chips from hit-and-run accidents, fiber trace evidence left at the scene of a crime, and explosives, including homemade explosives. Closely related and using similar methodology to criminal forensics is the determination of authenticity or counterfeit products. In this first example, the analysis of a street drug mixture will be presented. powdered material was confiscated at a crime scene and analyzed using SurveyIR. At left is an image of material pressed in a compression cell. Two disparate areas are noted. Infrared spectra were recorded from these two areas and are shown at right. From the analysis of these data, it was concluded that the powdered material consisted of a mixture of heroin hydrochloride dihydrate and sucrose, or common table sugar. Mixtures are very common in narcotics investigations and are problematic for conventional infrared spectroscopy analyses because the spectrum exhibits contribution from two or more materials. With FTIR microscopy, mixtures can be analyzed conclusively and rapidly, and by separation of the components under the microscopes, and recording their spectra independently. The analysis of paint chips left on surfaces in hit-and-run accidents provides important physical evidence that can link a suspect to a crime scene. Automobile paints can be complex, consisting of numerous stratified layers. In this example, the paint chip exhibited 6 distinct layers, as shown at left, observed under oblique illumination. Material from each of these layers was isolated, and the infrared spectrum recorded, shown right. Although each layer of paint consisted of more than one component, the infrared spectra exhibit distinct features consistent with the chemical stratification. By measuring multiple layers, more evidence and confidence in identifying the suspect can be obtained. This is another example pointing to the power of FTIR microspectroscopy in resolving complex samples observed microscopically and isolated using microspectroscopy optics. Fibers are commonly encountered contaminants, but also can be trace evidence in criminal forensic investigations. Fibers can be readily identified using SurveyIR. In the image at the left, several fibers are observed in the field of view under oblique illumination through the diamond ATR element. These fibers were sampled from a surface using tape. The fiber spectra can be selectively measured using diamond ATR. The blue spectrum at top right was recorded from a clear fiber exhibiting a very regular shape and is identified as polyethylene terephthalate, or PET. A blue fiber is also observed in the image on the left. At bottom right, the infrared spectrum of the blue fiber is shown, identified as cotton. Cotton is primarily cellulose, and it's a natural fiber, so microscopically its habit is different, exhibiting irregular surface morphology. We also see that the infrared absorption spectrum of the synthetic versus natural fiber are very different and can be readily differentiated. SurveyIR brings the solution closer to the problem. This should lead to wider use of FTIR microspectroscopy in criminal forensics through an easier to use and more affordable solution. Providing accurate and reliable data is the key for successful prosecution in criminalistic investigations. Through identification of components in a mixture, more information is provided, tying the suspect to the collected narcotic material and supply chain. By providing detailed analyses of paint chips left at the scene of hit-and-run accidents, a suspect vehicle can also be tied to the crime scene. An important issue in criminal forensics is the microscopy backlog. Traditional FTIR microscopes are relatively expensive and complex. SurveyIR is both easy to use and affordable, requiring a low cost of ownership and little training. SurveyIR simplifies infrared microscopy. In conclusion, SurveyIR provides affordable performance, yet very versatile microspectroscopy capabilities. Small samples from various substrates and of various morphologies can be readily identified. The image quality and clarity allows easy visualization of samples with 3 sample illumination modes. Images can be saved, analyzed, and documented using an onboard megapixel camera. SurveyIR has a lot of flexibility in the infrared spectroscopy measurements. Samples can be measured in reflection, ATR using diamond or germanium elements, and transmission. SurveyIR is user-installed and requires minimal training. Please contact Czitek for answers to any questions and for more information.